Hello everyone, in this video we're going to talk about how to solve equations with rational exponents. So if you see here, now we're dealing with exponents that are rational, meaning fraction as an exponent, and in all three scenarios we're going to talk about how to ultimately get to the point where we solve for x. But yeah, let's just get started. So you're really only going to have to do maybe one or two videos or two examples of this. If you want to skip maybe to the last one or do the first one and the last one, and I think it should be enough. But I'm going to go through 4 examples just to make sure we cover all of our bases. In case you really need to do more examples, you can feel free to watch the entire video. So the first thing we want to talk about is how do you convert, what does it mean to have this rational exponent? Now, we spoke about in the video about how to convert from a rational exponent to a square root or a radical function. So we're going to do just that. Remember that the denominator is going to be inside the radical or going to be outside the radical as the index. So we're going to take this, 2, and we're going to put it outside the square root. I'll go ahead and write it here. The denominator has the index, and then this 1 is going to stay attached to this 5 minus x, and that's going to go inside the square root. We have 5 minus x to the 1 power, and this should equal to 4. Should be a 1 right here. You can see that. Now, we're going to take this problem, we're going to solve it this way. We're always going to convert all of our exponents to square roots or to radicals, so we can simplify it that way a little bit easier and just be more consistent in that way. You can technically solve it both ways. You can go ahead and solve this problem the way that it is written, right, or the way that it's in this format, but I'm going to stick to this way doing it so that you can follow a more consistent approach. If you want to see how to solve it this other way without having to convert to radical form, just let me know and we can go down Zoom and we can talk about how to do these problems. So let's begin. I'm going to rewrite the problem just so I can have it here. Square root of 5 minus x to the 1 power equals 4. Now, here, our first scenario, our first thing we want to definitely do is we want to isolate the radical, as we did before. Notice how the radical here is already isolated, and now we can get to do the exact opposite of this index. The index here is a 2, which is a square root. The opposite of a square root is a square. So we're going to do just that. We're going to square the left-hand side and the right-hand side. By doing that, the square root and the square will cancel, leaving us with just 5 minus x to the 1 power equals to 16. Now, anything to the 1 power, or to the first power, is going to be just itself, right? 5 minus x to the 1 power is just 5 minus x. And solve for x, we just move everything to the other side. We're left with negative x equals positive 11. Divide both by a negative 1. You're left with x equals negative 11. Remember, we want to plug this back into the original problem. Now, you have the choice, and whatever you prefer, to plug it into the one that we wrote in the radical form. Sorry about that. The one that's in radical form, or you can plug it back into the original problem. Since both of these examples are the same, right? Since this is just written in a different format, it doesn't matter which one you plug it into, this one or this one. I prefer doing it in this way because I know how to simplify square roots a lot easier. So I'm going to go plug it into the original problem, into the square root form, and I'm going to solve for x and check it to see if the answer works. So I have the square root of 15 minus negative 11 to the 1 power equals 4. Inside the parentheses we have minus the negative, which changes to plus, so I have 15 plus 11. Sorry, not 15, that's 5. I read my parentheses wrong in the original problem, and this should just be a 5. 5 minus negative 11 changes to 5 plus 11, which is 16. There you go. So I have 16 to the 1 power equals 4. 16 to the 1 power is just 16, so I really just have the square root of 16. And that actually is 4 equals 4. Since this answer works out, I have a solution. If you feel like this is enough to sort of help you remember how to convert from rational exponents to radical form, then go ahead and pause this video or stop it and continue working on the homework problems. If not, keep at it, because some of these examples get more complex as we move on. So it wouldn't hurt to keep watching the video. Okay, in this scenario, we have 2 to 2/3. So remember, the denominator is going to be the index. So we have the cube root of the rest, x plus 1 squared. And that should equal 9. So once I've converted from rational exponent to radical, I remember the first thing I want to do is isolate the radical. Here, notice how the radical, there's nothing in front of the radical, nothing behind it. It's already isolated. So I look at the index, and I'm going to multiply it or raise it to the exact power. So the cube root of x is now going to be raised to the 3rd power. And I do the same thing to both sides. When I do that, the cube root, here, I'm going to rewrite this problem so that you don't get confused with which was our original problem. Now copy it down over here again. The cube root of x plus 1 squared equals 9. I'm going to raise it to the 3rd power, to the 3rd power. The cube root and the cube are going to cancel each other out, leaving me with x plus 1 squared equals 9 to the 3rd power, which is 9 times 9 times 9, which comes down to 729. Now, to get rid of this square, right, I want to do the opposite of squaring, which is square rooting. So I'm going to take the square root of the left and the square root of the right. The square root and the square are inverses, so that cancels, leaving me with x plus 1 equals the square root of 29, which is actually going to be 27. This parenthesis can technically disappear since nothing is happening around them. When you solve for x, you subtract 1 on both sides. You're left with x equals 26. Now, I want to plug this back into the original problem and confirm that I have a solution. So I'm going to do this as the cube root of 26 plus 1 squared. I want to find out if that's equal to 9. So I do everything inside first. I do parentheses and exponents and all that other stuff. So I have the cube root of 27 squared equals 9. 27 squared is actually 729. So I have the cube root of 729. Now the cube root of 729 is going to actually equal 9, because 9 times 9 is 81, and 81 times 9 is 729. So 9, in fact, equals 9. We have a solution at x equals 26. Let's try one more. All right, why don't we go ahead and pause this video here, and you try it yourself and see if you can get the solution. So the first thing that we want to do is convert this from a rational exponent to a radical form. Remember, the denominator is the index. So we're going to write this as the square root of 1 minus 4x to the 3rd power. This is the problem that I want to solve in radical form. So I'm going to write it again over here so I can show my work. I have the square root of 1 minus 4x cubed equals 27. Remember, I'm going to look at the index. Since I know that the radical is completely by itself, I can do it to the index and raise it to that power. So since it's the square root, the exact opposite is to square it. So I'm going to square the left, square the right. The square root and the square cancel, leaving me with 1 minus 4x cubed equals 27 squared. 27 times 27 is 729. And now to solve for x, I need to look at this cube value. And to get rid of the cube, I do the exact opposite, which is cube rooting. So I'm going to take the cube root of the left, and that looks ugly. The cube root of the right. On the left, the cube root and the cube cancel, leaving you with 1 minus 4x. And on the right side, the cube root of 729, as we've discussed before, is 9. Because 9 times 9 times 9 is 729. Here I just solve for x by moving things to the other side. I'm left with negative 4x equals 8. Divide both by negative 4. X equals negative 2. Again, I want to plug this back to the original problem and see if the solution is correct. So I have the square root of 1 minus 4 times negative 2 cubed equals 27. I'm going to do parentheses first. I have negative 4 times negative 2, positive 8. So I have the square root of 1 plus 8 to the third power equals 27. 1 plus 8 is 9, so I have the square root of 9 to the third power equals 27. 9 to the third power is 729, so I'm looking for the square root of 729. And the square root of 729 comes down to actually 27. So 27 equals 27. We have a solution at x equals negative 2. Alright, this is the last example where I have terms on everything on both sides of the equation, and I still have a rational exponent. So if you can do problems like this, you can pretty much solve any example you can with these types of problems. Go ahead and pause it and give it a try. Okay, as before, as always, we're going to convert this to radical form. So I'm going to do this as 4. I have the cube root of 5x plus 1 to the 1 power plus 10 equals negative 6. Remember, the very first step that you want to do once you convert it to radical format is you want to isolate this radical. Meaning we're going to do PEMDAS backwards, get rid of the 10, get rid of the 4, and then solve your way there. So I'm going to write PEMDAS here so you can sort of see as an example how we go backwards. Remember, we want to go backwards to solve. So we're going to do SADMAP. We'll start with addition and subtraction. I have this positive 10, so I'm going to subtract 10 on both sides. Leaving me with 4 times the cube root of 5x plus 1 equals negative 16, right, because these cancel. Now I look at multiplication and division. To get rid of this 4, I divide by 4 on both sides. I have the cube root of 5x plus 1 to the 1 power equals negative 4. Now that the radical is by itself, I can get rid of that cube as the index, right? And we're taking the cube root, we're going to do the exact opposite by raising it to the third power on both sides. We do that to both. The cube root and the cube cancel, leaving me with 5x plus 1 to the 1 power equals negative 4 times negative 4 is positive 16. 16 times negative 4 is negative 64. Remember that anything to the 1 power is just itself, so it is okay to erase this part, and I can just solve for x now. Subtract 1, 5x equals negative 65, divide both by 5, and you get x equals negative 13. Of course, we're going to plug this back to the original problem and check that it works, and then we can call it a solution, or if it doesn't, an extraneous solution. We have 4 times the cube root of 5 times x, or 5 times negative 13, plus 1 to the 1 power, plus 10 should equal negative 6. So I do everything inside the parentheses, which is going to be in here, this part first. So I got 4 times the cube root of 5 times negative 13 is negative 65, plus 1 to the 1 power plus 10 should equal negative 6. Inside the parentheses, I have 4 times radical, the cube root of negative 64 plus 10 equals negative 6. The cube root of negative 64 is negative 4, because negative 4 times negative 4 times negative 4 is negative 64. So I have here 4 times negative 4 plus 10 should equal negative 6. Negative 16 plus 10 should equal negative 6, and negative 6 actually does equal negative 6. We do have a solution down here at x equals negative 13. Alright, so let's just review real quick. To recap, remember, ideally the very first step is to isolate the radical. Leave everything, use StatMep by doing PEMDAS backwards to isolate the radical. And then you want to convert that rational exponent to radical form. Right? Remember that x to the AB, the denominator is the index. And then the numerator stays with the x value. You first want to convert it to a radical form. Once it's in radical form, you can then go ahead and start solving both sides by raising it to the index, leaving it by itself. So when you solve for x, you can have up to 2 answers, right? If it's quadratic or if it's a regular function. But whatever it is, whenever you get your answers at the very end, you want to plug this back into the original problem. Ideally, it's in the radical form one, so you can just solve for x to see if you have a solution or not. All right, guys, I hope this helps. Please don't hesitate and ask if you need any help or anything. I'm available in Zoom. Send me a message through my Remind. We'll get on there and we can talk about it. We can solve another example or two just to clear some things up. You guys are doing a great job, and keep up the good work. It's almost summer. Talk to you later.